Hi, welcome to our pre-calculus. The topic today is finding solutions in an interval for a basic trigonometric equation involving tangent, cotangent, secant, or cosecant. Let me just remind you of the previous lecture where we learned how to solve the cases with sine and cosine. Sometimes it's good to have a picture so that we have confidence about the answers that we give in these cases. We are going to come back to the issue of approximate answers later on, but it's good to take a preview at this time. Suppose we want to solve a simple equation, that is, what is the solution of cosine of theta equals to some number. We're trying to find an angle whose cosine is a certain number. Suppose they tell you solve cosine of theta equal to 1/2. Of course, one option is to go look up at the table, but it's better to have an intuition about it so you don't rely on tables. So what we do in all of these cases is draw the unit circle, draw the x and y axis, and then for the case of each of these trig functions, we are going to do slightly different approach. For cosine of theta equal to some number, suppose you have this number given to you, say 1/2. Remember, the radius of the unit circle is 1. You draw a line segment size of the number they gave you. So if this was 1/2, you draw this to 1/2 point. Then you draw a vertical. Draw a vertical until you hit the unit circle. The two angles that you see formed here, these are the solutions. The cosine of either of these two angles is theta, is b, and both of them are between 0 and 2 pi. So again, you draw the line segment equal to this number, and then draw a vertical. You connect the intersection points to the origin. These are the two intersection points. You connect them to the origin. There is one angle here and another, perhaps a big angle that forms going all the way to quadrant to quadrant 3 or 4. Okay, what do we do with the sine case? In the sine case, we draw a line segment equal to the number that is given to us on the vertical. We draw a horizontal line, connect these 2 points to the origin. It forms two angles. They form two angles, and these are the two solutions between 0 and 2 pi. For the case of tangent, it's a bit different. We are going to draw a tangent line at the right end of the circle. Okay, we draw this tangent line. Whatever tangent value is given to us, say it was given like 1.5. We draw this line segment equal to the length, so that its length is equal to this number. We connect that point to the origin and keep going, so we get two intersection points. The two angles that are solutions of this equation between 0 and 2 pi are the two angles that you see drawn here. In all these cases, if the number that is given to you was a negative, instead of drawing on the right, you draw it on the left. If a was negative, instead of drawing up here, you draw it down here. And if c were negative, you just draw it down here. Now, how about the other three functions, secant, cosecant, and cotangent? It's possible to draw similar pictures, but perhaps we are going to use the reciprocal identities to get the answers in those cases. So let's go take a look at some example here. Tangent of theta plus 1 equal to 0. We want to find the solution in the interval from 0 to 2 pi. So that obviously tells us that tangent of theta is equal to -1. Now, of course, we could go ahead and look up in our table or in our unit circle and get our angles. So we say theta is equal to 3 pi over 4, or theta is equal to 7 pi over 4, and then that would be done from the table. What if the table is not available to us, or we want to have an approach that would be working for us if this number wasn't such a nice number? What do we do in that case? So as we said up there, you draw your unit circle. So here's a unit circle in the coordinate system. You draw the tangent axis. Tangent axis is this axis here. This number -1, when it is negative, you draw it down here. Remember, the radius of the circle is 1, so when they say -1, you know you have to stop at the bottom of the circle. Wherever you stop, you connect to the origin and continue. The angles that you get, one of them is this one, and the other one is this one. Now you can reason your way to the fact that this angle is 3 pi over 4 and this large angle is 7 pi over 4. These are between 0 and 2 pi. So on Alex, you enter this with a comma, 7 pi over 4, and then you're all done. Similar example, secant of theta plus 1 equal to 0. So that means secant of theta is -1. Well, secant, we remember that is 1 over cosine. So if you have a fraction, remember, if you have a fraction is equal to some other fraction, if you take the reciprocal of this, you can also take the reciprocal of that one, and they are still equal. So if, or you say, I flip this fraction, it becomes cosine. Flipping -1, well, it gives us -1 again. So we are back to the equation that cosine of theta is equal to -1. Well, now this goes back to the topic that we had in the previous lecture. If cosine is given to us, what do we do? Again, you remember, you can look up in your table and see that the angle is pi. There's just one answer. However, if you want to have your own approach to it, you draw the unit circle. Remember, the radius of it is 1. The horizontal is the cosine axis. You go ahead and find -1 in it. -1 is, so go to -1. This is where -1 is at. At that point, you draw a vertical and look for intersection. There is just one intersection, or the two of them have merged. The angle that we are looking for is just this angle. There's just one answer, and the answer is just pi. If you want to say two answers, the second answer is also pi. So in some sense, there are two answers, pi and pi again. Here's another example. We say radical 3 cotangent of theta -1 is equal to 0. So cotangent of theta, radical 3 cotangent of theta is equal to 1. Therefore, cotangent of theta is 1 over radical 3. Now we remember cotangent is same as 1 over tangent. 1 over tangent is 1 over radical 3. Now if we flip both of these two fractions, so it says tangent of theta is radical 3. We go ahead in our table and look it up that this angle is pi third, and also it turns out 4 pi third. How can we eyeball this thing and make sure we are on the right track and numbers make sense? The way we do is take the unit circle, draw the tangent axis to it. Tangent axis is this axis. We draw radical 3 here. Radical 3, I draw a line segment that would be equal to radical 3. It's like 1.7 and something. From this point, we connect to the origin. Just look at this angle. Which famous angle does it look like? If it wants to be a famous angle, that's going to be obviously 60 degrees. How about this one? Well, that is pi plus another pi third. Pi plus pi third will be 4 pi third, and so you're done like that. And then here is a similar problem with tangent of theta, cotangent of theta. This becomes cotangent of theta equals -1. You reciprocate both sides, cotangent of theta becomes -1. This looks like the problem we just know. Yes, well, that is same as this problem. Now we have the tangent and we have the answer to that problem, so we can quickly say 3 pi 4 and 7 pi 4, and that concludes our attempt at this. So important thing was to make use of these three pictures to get an intuition about the equation that we are solving in case the numbers were not such friendly numbers. This gives us a better grasp of the situation. Okay, until next time, good luck and God bless.